Hi there, my name is Adam Nagy and I will be presenting the second part of the Introduction to Revit Programming. I joined Autodesk back in 2005 and first started supporting the manufacturing product APIs, then AutoCAD related APIs, and have also been supporting the AEC product APIs for a few years now. Today we will learn about the Revit API through creating a room renumbering add-in. The way this add-in will work is it will ask the user to keep picking rooms and it will set those rooms numbers starting with 1. It also needs to make sure that 2 rooms do not have the same number as a result of this renumbering, because Revit would not like that. While implementing the add-in, we'll see how to find out what exact room parameter needs to be changed, how to pick objects in the user interface, and how to find out using filtering if a room is already using the number we are trying to set to another room. But before we start programming, I'll show you quickly how the add-in will work once it's finished. This might make it easier for you to follow what I'm doing while implementing the add-in. As you can see, the room numbers in this drawing are not in order. So I start my command under add-ins, external tools, command, room renumbering, and I keep picking rooms. 1, 2, 3. And notice that if a room already has the room number that I'm assigning to the picked room, then that room will get the picked room's number. For example, here is room with number 4, but I want this room, which currently has the number 5, to have the number 4. And when I pick this room, my add-in swaps the room numbers nicely. And I already finished with the renumbering. You've already learned in Introduction to Revit Programming Part 1 how to create an add-in, and that presentation also contained templates for creating ready-to-run Revit add-ins where you can just add your own code. This is what we are going to use for our project as well. So I just create a new project, File, New Project, select the template, and then name the add-in. And it's done. One really nice thing about these templates is that they also take care of the registration and unregistration of your add-in. When you build your project, then your add-ins manifest file is automatically filled with the correct data and copied over to the right folder so that Revit will load your add-in the next time it's started. And if for some reason you do not want Revit to load your add-in, then you can just clean your project, which automatically removes your add-ins manifest file. So we have our add-ins framework now, and we need to start implementing our add-ins functionality. First of all, we need to let the user pick the rooms he wants to renumber. For this, the API provides the necessary functions under UI document.selection. Each of these functions have quite a few overloads, so you can use them with different parameters. In our case, we just want to ask the user to keep selecting rooms one by one. Therefore, we use pick object. First of all, we need to get access to the UI document that you can find in the command data parameter. So I say UI document that I find under command data application and active UI document. Then we need a loop inside which we can keep asking the user to pick a room in the user interface. So I start here a loop. Inside this loop, I can keep calling the pick object function. Which returns a reference. A reference object is a stable reference to a geometric object in a Revit model, which is used when creating elements like dimensions. We set the type of object we are interested in and provide a prompt for the user. So the object type would be element, and let's provide a prompt. and then the returned value is a reference. If I set the while expression to true, then how will we ever get out of this loop? Well, in case the user cancels picking, Revit throws an operation cancelled exception that we can catch, and this will take us right out of the loop. There is also an operation cancelled exception under the system namespace, so make sure that you are using the correct one under autodesk.revit.exceptions. So I can put here the try catch part. And what I need to catch is autodesk.revit.exceptions operation cancelled exception. You can see that some of the overloads of pick object also requires an object with interface iSelectionFilter. If you want to specify what exact object types are allowed, then this is the interface the class you need to create must implement. That's what we'll do as well to make sure that the user can only select rooms. So I declare my class here, public class mySelectionFilter, which needs to implement iSelectionFilter. I remove the region because I don't need it here. As you can see, this interface has two methods that can be overridden. One is the allow element, which is used to specify if an element is allowed to be selected, and allow reference, which is used to specify if a reference to a piece of geometry is allowed to be selected. If we were to pass object type face or point on element, in that case the allow reference function would be called. But since we are restricting the selection to elements instead, therefore it's not called, and so we can return either true or false. It makes no difference. So I can just return, let's say, true. And inside allow element, we return true if the selected element is a room, which I can check with the is keyword. Also, as you can see, Visual Studio automatically offers adding the namespace that the room class resides in. Now we can use an instance of this class and pass it to pick object. New mySelectionFilter, and it's done. A reference also contains information about the element the geometry is part of, and this is what we need to get to the room object. So under the selection reference, I will find element, but I need to cast it to room. How can we find the room parameter we need to set in order to change the room number? We can use Revit lookup for this. The Revit lookup tool comes with the Revit SDK, which is part of the Revit installer, so you do not need to download anything extra for this. In part 1 you could already have a look at it, and now we will use it to look inside the room object. For this I just need to select a room, then run add-ins, Revit lookup, snoop current selection, and then I can see all the parameters it has. Here you find the number. If I check the internal definition, then I can also find the built-in parameter name, which is room number. This is what we will need. However, in this case we are lucky because the room class also has a dedicated property called number, which makes changing the room number even easier. To keep track of the room number we are assigning to the picked room, we need to create a variable. Let's call it simply room number, and the value will start with 1. Then we use it to set the room number. We also need to convert it to string. And then we just need to keep incrementing it inside the loop. We would need to make sure that no other room is using the number we are trying to assign to the selected room. So we need to search for existing rooms in the database. Whenever you want to get access to any of the database objects, you have to create a filtered element collector object and specify the document and perhaps view that you are searching in. There are loads of Revit filtering classes that help you get back the exact object you are looking for. You should narrow down the set of objects as far as possible using the Revit API and only then use generic API including link queries to filter down the selection to the specific element you want, because this way your code will be much faster. In our case, we can get back the element we need only using Revit API. So first we need to create a filtered element collector. We can also specify the object type we are looking for using the of-class function, which dramatically reduces the element set and so makes further filtering quicker. In this case, however, we cannot look for a room, but can look for its base class, which is called enclosure. Then we can narrow down the collection to the exact room we are looking for using where passes, which requires a filter that is based on a specific rule. A rule requires 3 parameters: a provider that returns the parameter's value, an evaluator that tells Revit how we are comparing the value, and the value itself, in our case a string that we are comparing to. In this case, we are checking if the room number parameter of a room equals to the string we pass in. As I mentioned, we need to start with a filtered element collector object. So let's declare it here, filtered element collector. And we need to pass in the document we are searching in, which is under UI document.document. Then we can narrow down the search to a specific object type using the of-class function. So we just need to pass in the type. You may remember that we cannot use the room class, but we can use its base class, which is the enclosure. So you can either use this, but there's another option, using the where passes and then passing in a specific filtering class called the room filter. It's up to you whichever you choose. Both of them have similar results. And then we need to specify which specific room we are after using a parameter filter. So we need collector where passes again, and this time we'll pass in our own filter called filter. And this will be filtering based on an element parameter. Therefore, we need an element parameter filter, which needs to be based on a specific filter rule. So we also need to specify that. Let's just call it rule. The room number parameter is a string, so we need a filter string rule. Filter string rule. And this rule needs three things mainly. First of all, a provider, which will provide the value that we are checking.